Hi, this is Chris with Sanderson Test Prep, and we are continuing in section 4 of practice test 1, questions 9 through 12. So let's take a look at questions 9 and 10 here, which this information that we see refers to both questions. So they give us an equation, A equals 1052 plus 1.08t, and then the paragraph below reads, the speed of a sound wave in air depends on the air temperature. The formula above shows the relationship between A, the speed of a sound wave, in feet per second, and T, the air temperature, in degrees Fahrenheit. And it's always important whenever you have something that has any number of variables, but especially if it has multiple variables, so more than one, you want to make sure that you keep track of what each variable represents. So in this case, A is the speed of a sound wave, T is the air temperature. Okay, so let's jump into question 9. Which of the following expresses the air temperature in terms of the speed of a sound wave? And the most important thing that you can do on any math question to give yourself some framework of what they're asking you is to preview the answer choices. Just take a quick look and see how the answer choices are displayed. And here we can see that every answer choice isolates T. So even if we weren't too sure based on reading the question itself about, oh wait, which one represents air temperature, or what does it mean when they say in terms of, and how do I start approaching this question, we know we just have to get T by itself. So from this equation above, A equals 1052 plus 1.08t, we're going to try to isolate T. So let's rewrite that here so that we can work with it. A equals 1052 plus 1.08t. And to solve and isolate T, first we have to subtract 1052 from both sides, which will leave us with A minus 1052 equals 1.08t. And then we're going to divide both sides by 1.08. So when we do that, the 1.08 cancels out, and we are left with A minus 1052 over 1.08 as our value for T, which matches up with answer choice A. Now, let's move on to question 10. And here it says, at which of the following air temperatures will the speed of a sound wave be closest to 1,000 feet per second? So they're asking about air temperature, which we know is T, and they're giving us a value for A, 1,000 feet per second is A. So since they're asking for T, question 9 actually helps us out quite a bit because we already know how to isolate T. So if T is equal to A minus 1052 divided by 1.08, then we can use that equation here to solve this. And when we go to use that equation, we just have to figure out what we're supposed to plug in for A. And remember, A is the speed of a sound wave in feet per second, which they tell us here is 1,000 feet per second. So we're plugging in 1,000 for A in this equation in order to solve. So let's take a look and see what happens when we do that. So if we plug that in, we're going to get 1,000 minus 1052 over 1.08. And remember, this is the calculator section, so I would not recommend trying to do mental math on this. You still want to do mental math where you can to save time, but this is certainly complex enough that you should rely on a calculator. And when we do that, it comes out to a negative 48.15. It's actually 148 and change, but for our purposes, we can put it down as negative 48.15. And it says closest to, and keep in mind, if it does say closest, that means it's okay if your answer choice does not come out to be the exact value. Here, our closest answer choice to negative 48.15 is negative 48 degrees Fahrenheit for our answer to number 10. Now let's move on and take a look at question 11. So here, which of the following numbers is not a solution? And I do recommend underlining that when you read the question, even though they put it in all caps, it's so easy to forget. And I see test takers miss questions even when knowing how to do the math because they're just not careful about recognizing that it was asking for the exception or the not scenario. So make sure that if they say not a solution, that we're reading that and applying that correctly. Here they give us this inequality, and really we're just going to combine like terms and solve this like we would any other equation or inequality. But the tricky part is recognizing that they're looking for what's not a solution. So we can move the variables to the right and the constants to the left, or vice versa. I personally, and again, this is going to be personal preference, so if you choose to do it a little bit differently, it's perfectly okay, but I prefer to move the variables to the side where the coefficient on the variable is going to be positive. So I would subtract 3x from both sides on this. So if we do that, subtract 3x from both sides, and I'm going to write this out as 2 steps. You can do it as 1 if you'd like, but that way we just have x minus 3. We add a 3 to both sides, and when we do that, we will get negative 2 is greater than or equal to x. Now from here, if it's more comfortable to you, you can switch this around and rewrite it as x is less than or equal to negative 2. So whichever way you quote unquote see it better, that's the way that you want to write it out. And so here, if we have x is less than or equal to negative 2, then that means that our solution set would include negative 2 and anything less than or equal to negative 2. But the question, remember, is asking for which one is not a solution. So they're saying basically which answer choice is not less than or equal to negative 2. Negative 2, negative 3, and negative 5 are all either equal to negative 2, like in answer choice B, or less than in answer choices C and D. A is the only answer choice that would not be part of this solution set. And if it helps, you can. You don't have to. But if it helps to graph out your solutions on a number line, so if this is, let's say, 0 and this is negative 2, you would fill it in because it's less than or equal to. So you fill in the circle when it's or equal to, and it would be everything in this direction would get filled in as part of your solution set. So the only one that's not part of that solution set would be negative 1. Negative 1's over here on the other side of negative 2. Everything else would be included as part of that solution. And if that helps you visualize it, again, you can always write that out, but you don't have to on a question like this. So remember, with inequalities, we solve them the same way we do regular equations. The only thing that makes this one a little bit trickier is that it has the not in the question that we want to make sure we're careful about recognizing as we read through it. Okay, up next we'll take a look at question 12. And question 12 says, based on the histogram above, which of the following, which is closest to the average number of seeds per apple? So sometimes you'll see it displayed like we see here as a histogram. Sometimes you'll see this same concept tested as a frequency table. But the main thing for us to keep in mind about this is that whenever you see that you have a frequency, for example, number of apples, and then a value that that frequency is going to be applied to, in this case, number of seeds per each of those apples, what we want to do is multiply those values to figure out our total. A lot of people here, when they go to find average, they know how to find average regularly. You add them up and divide by the number of terms, right? So that's something that people recognize, but then when they see it in a histogram or frequency table, it becomes a lot more challenging. So let's take a look here and see if we can calculate an average using this histogram. So here, if you have 3 seeds per apple in this first column, and you have 2 apples that have 3 seeds each, you have to multiply those values. This represents 6 total seeds. And remember, they're asking for the average seeds per apple. We're trying to add up all of the seeds that we have for this question. So let's do the same thing for this next column. You have 5 seeds per apple for 4 apples. So 5 times 4, that would account for 20. So as we start to piece this equation together, we have 6 plus 20. Here, you have 6 seeds in just 1 apple. So that would be 6 times 1, that's 6 as well. You have 7 seeds in 2 apples. That would be 7 times 2, that's 14 total seeds there. You have 9 seeds in 3 apples. 9 times 3 would give us 27 total seeds there. So we have to add all of the seeds up, and it's per apple, so we have to divide by the total number of apples. Now, one thing that's really nice, in most of these questions, somewhere in the question, they will actually give you the number of apples that you're looking at, or the number of whatever it is for that particular question. But you could say, well, here it's 2 plus 4 plus 1 plus 2 plus 3, but you don't have to actually add that together. They tell us right up at the top that you're talking about 12 total apples, so we can divide this entire thing by 12. And again, this is calculator section, so I don't recommend trying to do this with mental math. You can, but we don't have to. So we can use a calculator for this and add that all up together. So that comes out to 73 divided by 12, which would be 6 1/12. And again, just like we saw on a question on the last set, number 10 had a closest to. This is also a closest to type of question, which means it's okay if your exact answer comes out to be not the same as your answer choice, but they're looking for the answer choice that's closest to that exact answer, which means it would be answer choice C for number 12. And that's it for this question set. We're going to continue on in our next video and take a look at our next few multiple choice questions here in section 4 of practice test 1.